Hi everyone, I'm now going to show you how to do question 7 in the exercise 10G problem solving with 3D shapes. I'm not going to go through how to do question 4 because if you can do question 7, you can definitely do question 4, so I'm kind of working backwards. Okay, let's have a read. Roberto is flying his kite, so you can see him here, with the aid of a southerly wind. He lets out a 54 meters of string and the kite is at an angle of elevation of 37 degrees. His friend Geraldo stands to the west 95 meters. So that's him here. So he's 95 meters away. So the first question says, how far is Geraldo from the kite? So you're actually assuming, because if I show you a bit more like this, so you can actually see that this question has a very similar, it's actually the same shape to question 4 up here. Question 4 up here. You can see that they're both triangular based prisms. They're both triangular based prisms. So we are trying to find, so how far is Geraldo from the kite? So we are actually trying to find, I'll do it in a different color, the distance from here to here. And if I draw that out as a triangle, it would be this length and this length as well. And it is a right angle triangle. So I would use Pythagoras if I labeled this as C, this one as A, and this length as B. I can use Pythagoras, A squared plus B squared equals C squared to solve this. So I've got 95 squared plus 54 squared equals C squared. So C squared equals 11,941, and C is going to be the square root of 11,941. So that comes to be approximately 109 meters. So this length here now we know is 109 meters. All right, so that's part A done. Then it says, what is the kite's angle of elevation from Geraldo? So we can see the angle of elevation, let me use a different color, from Roberto. So it makes this shape here. So it's from the floor up to where the kite is. So if I'm following that same pattern with Geraldo, so it's going along the floor, which is this length here, and following up to his line of vision there. So it's actually this angle here that we're looking for. I'm going to label it as theta. So we either need to know this diagonal that goes across here, or we need to know this height here. And we actually have the information for this height here. So if I go back into my green triangle, you can see that I have a length of 54 here and an angle of 37 degrees here. Oops, sorry. So if I'm trying to work out what ratio to use, this is my opposite and this is, the 54 is my hypotenuse. So I'm going to use sine theta is opposite over hypotenuse. So sine 37 is opposite over 54. So times by 54 and times by 54 here. So my opposite side is going to be approximately 32.5 meters. So I now know that this length here is 32.5 meters. So if I go back now, I'm actually going to rub a bit of this out so it's not that much. I'll rub some of it out so we can actually see a bit clearer. So we have, right there. So let's go into purple. So we have the hypotenuse length of 109, that's the hypotenuse. We have the angle, that's what we're trying to find. And we have this length here, which is the opposite. So I'll be using sine again. So I've got sine theta is opposite over hypotenuse. Sine theta is 32.5 over 109. Then I'm going to take the inverse. So theta is sine to the minus 1, 32. Oh, that does not look like a 2. 32.5 over 109. And my angle is approximately 17.3 degrees. All right, so that's question 7 solved. Now go back and see if you can have a go at either question 4 or 5.